In this video, we'll be discussing the basic introduction to stoichiometry. So this is an intro. There's a basic introduction to stoichiometry. Now, we're going to be looking at the series of stoichiometry. This is the first one, stoichiometry 001. We want to know what stoichiometry is and why do we even study stoichiometry in chemistry. Now, stoichiometry is derived from two words, the stoichion and metron. Now, stoichion means atoms and metron means measurement. Stoichion means atom and metron means measurement. That's measurement there, so you write it well. Now, if you look at science and you look at the world of calculation, calculation is a very vital and important aspect of science. If you know that calculation is done in chemistry, you will know that stoichiometry is the foundation to understand every other calculational aspect of chemistry. Now, stoichiometry is divided into two. Stoichiometry is divided into two. Now we have the stoichiometry of composition. Then we have the stoichiometry of reactions. Now, for the stoichiometry of composition, we're talking about the composition of a compound. That's the first thing. We're talking about the composition of a compound or a chemical compound. All right? Number two, we talk about the empirical and we talk about the molecular formula. Now, we'll talk about the empirical formula and molecular formula and chemical composition of a chemical compound in stoichiometry of composition. But we'll talk about the stoichiometry of reaction. We will look at the relationship of the quantities of particles of atoms of elements in a balanced chemical reaction. I take that in another term. We'll look at the composition or the relationship between quantities of particles of atoms of elements that is involved in a balanced chemical reaction. So that is that on composition, on stoichiometry of reaction. Now, if you look at stoichiometry, why do we study stoichiometry? We study stoichiometry because it gives us the relationship between the quantities of atoms of elements in a chemical composition or a chemical reaction and moles. I take that again. It gives us the relationship between the particles of atoms of elements in a composition or a chemical reaction and of matter, of course, and moles. All right. Now, the question is, what is mole? Now, if you look at some textbook, you have it called mole concept. So what is mole concept? What is mole? Well, mole is the unit of measurement in chemistry. Of course, there are so many moles in the world. For instance, if I say 1 dozen of egg is equivalent to 12 eggs. All right? 1 dozen of egg is equivalent to 12 eggs. So what we are doing in chemistry is the mole is the unit of measurement of elementary particles in chemistry. As 1 dozen of eggs is 12 eggs, we have 1 mole of a chemical substance equal to the Avogadro number, which I'm going to give to you. Now, we can say 1 gross or a gross of stuff. A gross of stuffs is equal to X number. So you're going to find out. Now, we also have a score. A score of stuffs equals to how many stuffs. Now, in the Bible, you notice score is mostly used to determine the years of leadership or years or age of an individual. You can say 3 scores, 4 scores. If I say 3 score is equivalent to 20 times by 3, which is 60. So you know that 1 score is 20 and 3 score is 20 times 3, and that is 60. Now, for the gross, let me help you with that. Now, for the gross, we know that a gross is 12 dozen, which will become 12 times 12. And 12 times 12 is 144. A gross is 12 dozen. Dozen, 12 into 12. 12 times 12 is 144. So we can say that 1 mole is equals to 6.02 times 10 raised to the power of 23. 1 mole is equals to 6.02 times 10 raised to the power of 23. The number of atoms of elements is so much so that to quantify them, that's why we say a mole is a unit of used in quantifying elementary particles. And the elementary particles can be the atoms of elements. The elementary particles can be the molecules. The elementary particles can be the ions, can be the protons, can be the neutrons, or the electrons. A lot of that. Now, a mole equals 6.02 times 10 raised to the power of 23. That's about 602 sextrillion in number. All right. Now, if you know that, then we can now say, as we know that 1 dozen of X is 12X. So that 1 mole of stuffs in chemistry, 1 mole of atom of element, 1 mole of molecule equals to about 6.02 times 10 raised to the power of 23 of that stuffs. Now, we now move to another important concept. Now, another important concept we need to understand is that we're going to be looking at the relationship of mole in number 1 of substance of unknown masses. Relationship of mole of substance of known masses. Number 2, we're going to look at relationship of mole in a solution. Mole in a solution. Let me term this mole relationship. So, relationship of mole in a substance of known masses. Relationship of mole in a solution. So, we look also at relationship of mole in gas or gases. Relationship of mole in gases at STP, that is standard temperature and pressure. We look at relationship of mole in an ideal gas. Okay, now we look at relationship of moles in elementary particles. Now, let's pick up the first one. Relationship of mole in a substance of a known masses. Let's use the side of the board. All right. How do we solve that? The number of mole of substance is equals to the mass of the substance over the molar mass of the substance. The number of mole of a substance is the mass of that substance over the molar mass of that substance. If we know that, we can say the number of mole of a known mass of substance is mass of substance over the molar mass of that substance. Now let's ask a question. Let's say how many moles of sodium, how many moles of sodium is in 35 grams of sodium? How many mole of sodium is in 35 grams of sodium? Now, let's solve like this. We know that number of mole is mass. over the molar mass. Now, the first thing is, what is the molar mass of sodium? If you go to the periodic table, you will find out that sodium is written like this. Let me use the right pen now. Sodium is written like this. Over here, we have 11, and down here is 22.22999 stuff, like that, such value. But meanwhile, I want to use the molar mass of sodium to be 23. Now, this is called the atomic weight, and it's also called the molar mass of sodium. I want to take the molar mass of sodium to be 23, and now given that the mass of sodium 35, I'm not asked the question, how many mole of sodium is in 35 grams of sodium? So I have the mass of sodium to be 35. I have the molar mass of sodium to be 23. And if I do my calculation, 35 divided by 23, I'm going to have about 1.52 gram per mole, because this is gram, all right? This is gram, all right? This is gram per mole. So that gram, we cancel gram, and then I have 1.52 mole. Of course, the abbreviation of mole is abbreviated MOL, mole, all right? So there are about 1.5 mole in 35 grams of sodium. All right, let's say that is no more an element now, is a compound. Remember, we're talking about the relationship of mole in a known substance. Now, let's say how many moles of 40 grams of sodium chloride. How many moles of 40 grams of sodium chloride is in the compound sodium chloride? So how many moles of sodium chloride is in the compound of sodium chloride? So how many moles of 40 grams of sodium chloride is in the compound of sodium chloride? Now, remember or recall that number of mole, I need to change this thing. Number of mole is equals to the mass of that substance over the molar mass. So what I have is that the mass of the substance here is 40 grams. Then the molar mass of sodium chloride, sodium is 23, let's take that to be 23, and then chlorine is 35. Now, for your periodic table, sodium atomic weight or molar mass is 22.229 something. Then for chlorine is 34.45. But I decided to make the mass, the molar mass of chlorine to be 35 and the molar mass of sodium to be 23. So if I add this together, what I'm going to have is 23 plus 35, I will have 58. So 58 gram per mole. So what I have here is 58 gram per mole. And when I divide 40 by 58, I'm going to have the number of mole that is there. So I have 40 divided by 58. What I have is 0.689. So I'm going to make it 0.69 moles. So you see how to find the number of mole of a known substance. Now, for instance, let's say that the mole is given to you and then the molar mass is given to you. How do we find the mass of that stuff? Let's use this scenario. Let's say you are given the mole to be 0.69 mole as in the question, and then you are given the molar mass, okay, let's use capital M now, molar mass to be 58 gram per mole, and then you are asked to find the mass. So what's the mass over here? Now recall that number of mole is mass over molar mass. If you put your 1 here and cross multiply, mass is equals to number of mole times by molar mass. Now, what is the number of mole? That is 0.69 mole. Now, what is the mass over there? The mass over there is, do we have the mass? Yeah, the mass is given to us. No, it's not given. We have the molar mass. Molar mass there is 58 gram per mole. All right, now, we're looking at this scenario and then we're trying to find the mass using the format that we have had the molar mass, the number of moles, and the molar mass to be 58 gram per mole. So what we're going to do is multiply out that stuff. So what I have is 0.69 times by 58. That will give me about 40.02. So you see, 40.02 is approximately equal to this guy. 40.02 gram mole. We cancel mole. So having said that, you have known how to, you can now see how to find the mole relationship in a known in substance of known masses. Now let's go to solution. Mole relationship in a solution. Now for mole relationship in a solution, mole relationship in a solution. Well, I will not just go ahead and start giving you formulas, but I want to remind you of something. Do you recall that molarity is the same thing as molar concentration? Molarity is the same thing as molar concentration. Either I say molarity or I say molar concentration, I'm talking about the same thing. All right. Do you recall that molarity is written as capital M, or molar concentration is capital M? Now recall, molar concentration, capital M, is equals to number of mole over the volume. Now, where capital M is the molarity or the molar concentration, and N is the number of mole of the solution, and then that V is the volume of the solution, and that volume must be in dmq or in liters. It must be in dmq or in liters. Now, if your question is given to you in milliliter, you have to convert to liters. If your question is given to you in dmq, you have to convert in cmq, you have to convert to milliliters. Sorry, if your question is given to you in cmq, you have to convert to dmq. If your question is given to you in milliliters, you have to convert to liters. What I mean is that understand that 1000 cmq is equals to 1 dmq. Also understand that 1000 milliliters is equals to 1 liter. This is 1000, please. So 1000 milliliter is equals to 1 liter. 1000 cmq is equals to 1 dmq. Now, you also understand that 1 dmq is the same thing as 1 liter. Now, you need to leave your answer in molarity in either liter or in dmq, not in cmq and not in milliliter. Now, if you want to find the mole, because we said the mole relationship in a solution. Now, for the mole of this solution, molarity is equals to number of mole over the volume, so that the number of mole is equals to molarity times by volume, and the molarity is in mole per dmq, and you are multiplying by volume in dmq, or mole in liter, and you are multiplying by volume in liter. Whatever the equation is, you will know how to solve them. Now, we want to look at this question.